On December 1st, China unleashed what semiconductor executives worldwide can only describe as a strategic bombshell. Beijing declared that any lithography equipment containing 0.1% or more of Chinese rare earth materials now requires explicit export authorization from China, regardless of where it's manufactured or where it's being shipped. This isn't some minor administrative adjustment buried in regulatory fine print. This represents China wielding extraordinary leverage over the throat of the entire global chip industry. And the blade is pointed directly at ASML, the Dutch company that makes every advanced semiconductor chip on Earth possible. But to genuinely comprehend why this matters so profoundly, you need to understand what happened on September 30th, 2025, when the Netherlands made what could prove to be the most catastrophically expensive mistake in modern European industrial history. Without advanced warning, without presenting evidence, without even conducting a proper hearing, Amsterdam's Court of Appeals seized Nexperia, a Chinese-owned semiconductor manufacturing company operating on European soil. Dutch authorities removed the Chinese CEO, Kong Shu-jing, from his leadership position, appointed a foreign executive in his place, and transferred 99% of the company's shareholdings to a third-party trust structure. The Dutch government justified this extraordinary action by citing vague management deficiencies and unspecified economic security threats. But here's the critical detail they catastrophically overlooked. Nexperia wasn't just any ordinary chip company operating in Europe. After Wingtech Technology acquired it in 2019 for $3.6 billion, it transformed into the backbone of the global automotive semiconductor supply chain. The company manufactures and ships 110 billion chips annually. That's billion with a B. From Volkswagen to Toyota to Tesla, virtually every automobile rolling off assembly lines worldwide depends on Nexperia's components for critical systems like brake control, lighting infrastructure, and power management modules. And here's the devastating kicker that Dutch policymakers somehow missed. While the Netherlands believed they were seizing a valuable strategic asset, over 70% of Nexperia's actual manufacturing capacity physically sits in Dongguan and Shanghai inside Chinese territory. The Dutch government grabbed the corporate paperwork and legal ownership structures, while China retained control of the actual factories, the production lines, the equipment, and the workforce. Beijing's response arrived with surgical precision. 1 week following the seizure, Chinese authorities issued export controls explicitly blocking Nexperia's Chinese manufacturing facilities from shipping automotive semiconductors to European customers. Capacity utilization at those plants collapsed catastrophically from 90% down to under 10% almost overnight. Delivery capability to European customers crashed from 95% down to just 3%. The impact struck European manufacturing like a freight train traveling at full speed. Volkswagen's massive primary plant in Wolfsburg shut down every single production line, hemorrhaging over $100 million per day in lost output. BMW's Munich facility watched delivery timelines for high-end luxury models stretch from 3 months to 6 months, an unacceptable delay in the premium automotive market. Within just 2 weeks, European automakers collectively lost more than $3.5 billion in production output, while approximately 12,000 workers faced immediate layoffs or severely reduced working hours. Honda announced shutdowns at multiple North American manufacturing plants, with one facility in Ontario, Canada, cutting production capacity in half indefinitely. The data reveals the brutal reality of this dependency. 86% of Europe's key industrial companies purchase chips directly from Nexperia's Chinese manufacturing facilities, and roughly 1/3 of automotive supply chain companies utilize Nexperia as their exclusive semiconductor supplier. You simply cannot switch suppliers overnight when automotive-grade certification processes require months or even years of rigorous testing. By November 5th, the German Association of the Automotive Industry issued an ultimatum to the Netherlands, threatening to invoke Article 17 of the EU Chips Act to bypass Dutch governmental control entirely and restore semiconductor supplies. But that confrontation was merely round one of this economic conflict. The December 1st rare earth export controls represent China's genuine leverage point, and this strategic move targets the absolute crown jewel of Dutch industrial capability. ASML manufactures the only machines on Earth capable of printing semiconductor chips at the most advanced technological nodes. These extreme ultraviolet lithography machines cost up to $200 million each, weigh 180 tons, require 40 shipping containers just to transport, and every single one depends completely and utterly on Chinese rare earth materials for critical components. There are no alternatives. China controls approximately 90% of global rare earth refining capacity, and ASML has no viable substitutes available. The ultra-precise optical lenses that focus extreme ultraviolet light require cerium oxide, polished to 99.9% purity levels. Only Chinese refineries consistently achieve that exacting standard. American rare earth processing operations struggle to reach even 92.9% purity. Nowhere close to what semiconductor manufacturing demands. The magnetic positioning systems inside these lithography machines utilize over 10 kilograms of permanent magnets manufactured from neodymium, dysprosium, and terbium. These specialized magnets account for more than 30% of component costs in some critical systems, and China produces over 90% of global rare earth permanent magnets. When ASML previously attempted replacing these with conventional materials in experimental tests, production costs surged 40%, while system performance plummeted 30%. There are no economically or technically viable alternatives available. According to Roger Dassin, ASML's chief financial officer, the company maintains enough rare earth material inventory to sustain current production levels for approximately 8 weeks. After that buffer supply runs out, if Chinese export licenses experience delays or outright denials, ASML could witness monthly manufacturing output decline by 15 to 20 machines, a catastrophic reduction, with each machine representing hundreds of millions in revenue. Annual financial losses could exceed $3 billion for ASML alone. But the economic damage cascades far beyond one Dutch company's balance sheet. ASML supplies critical lithography equipment to Taiwan Semiconductor Manufacturing Company, Samsung, Intel, and virtually every major chip manufacturer operating on the planet. These foundries produce processors for Apple, Nvidia, AMD, Qualcomm, and the entire global technology ecosystem. A significant disruption at ASML doesn't just damage one company's quarterly earnings. It threatens the entire global semiconductor supply chain that powers everything from smartphones to artificial intelligence systems to advanced military platforms. The rare earth compounds ASML imports from China each year account for 26.4% of China's total rare earth exports. This isn't a minor dependency relationship. This represents a chokehold that can be tightened at Beijing's discretion. The timing of these moves reveals deliberate strategic calculation rather than reactive policy. Starting in December 2024, the United States placed Wingtech Technology on the Entity List, attempting to systematically crack down on China's semiconductor industry development. Then, on September 29, 2025, just one day before the Netherlands seized Nexperia, the U.S. Department of Commerce issued a piercing rule dramatically expanding sanctions to include all subsidiary companies where blacklisted entities hold more than 50% ownership stakes. This immediately severed Nexperia's ability to purchase key equipment and advanced technologies from Western suppliers. The Netherlands clearly calculated that with explicit U.S. backing and coordination, they could execute this corporate seizure smoothly without significant consequences. They were catastrophically, historically wrong in that assessment. China's message through these actions is crystal clear and unmistakable. If Western nations insist on restricting China's access to advanced chip-making technology through export controls and sanctions, Beijing will systematically restrict Western access to the raw materials fundamentally needed to build that technology in the first place. It's economic judo at the international level, using your opponent's structural dependencies directly against them with devastating effectiveness. The October 9th announcement included another particularly devastating clause requiring case-by-case government approval for any equipment used in producing logic chips at 14 nanometers and below, memory chips at 256 layers and above, and all related materials. This directly targets the most advanced semiconductor manufacturing processes that define technological leadership and military superiority in the 21st century. China spent 3 full decades methodically consolidating dominance over rare earth mining operations, chemical processing facilities, magnet production capabilities, and downstream component manufacturing. Chinese state-backed entities now control roughly 89% of global rare earth refining capacity, and nearly every critical aspect of high-performance magnet supply chains runs through Chinese territory or Chinese-controlled companies. Meanwhile, Western governmental efforts to diversify these supply chains remain years, perhaps decades away from achieving meaningful scale that could actually reduce dependency. In July 2025, the U.S. Department of Defense invested $400 million into MP Materials, making the American government the largest single shareholder in the only operational rare earth mine currently functioning within the United States. But industry experts and geological specialists warned that the U.S. won't achieve anywhere near self-sufficiency within the next year or even the next several years. Building genuinely alternative rare earth supply chains from mining to processing to magnet manufacturing requires 10 to 15 years of sustained effort and billions upon billions in capital investment. The European Union's Critical Raw Materials Act establishes ambitious goals to produce 7,000 tons of rare earth magnets domestically by 2030. That sounds impressive until you realize China currently produces over 150,000 tons annually. The scale disparity is enormous, and closing that gap requires not just money and time, but also expertise that has been systematically concentrated in China over decades. ASML's extreme ultraviolet lithography machines don't just use rare earth materials in 1 or 2 components. They're embedded throughout the entire system architecture. The laser systems that generate the extreme ultraviolet light require yttrium-based materials. The mirror coatings that reflect that light with 99.9% precision need specific, rare earth compounds. The magnetic levitation systems that position silicon wafers with nanometer accuracy depend on those neodymium, dysprosium, terbium magnets we discussed earlier. When you add up all these dependencies, you realize that approximately 30 to 40% of an EUV machine's critical functionality relies directly or indirectly on Chinese rare earth materials processed to specifications that only Chinese facilities can currently achieve at commercial scale and competitive prices. Back in the automotive sector, the crisis continues deepening with each passing week. Stellantis, the multinational corporation that owns brands like Jeep, Ram, Peugeot, and Fiat, announced in late November that it would temporarily idle 3 European assembly plants due to semiconductor shortages directly traceable to the Nexperia situation. French Economy Minister Bruno Le Maire called the Netherlands' seizure action economically reckless in a rare public rebuke of a fellow EU member state. German Chancellor Olaf Scholz convened an emergency cabinet meeting on November 15th, focused exclusively on semiconductor supply security. According to leaked minutes from that meeting, German automotive executives presented worst-case scenarios where production losses could exceed $50 billion by mid-2026 if the situation isn't resolved. That's not just corporate profits. That's GDP impact, tax revenue losses, and potentially hundreds of thousands of jobs across the automotive value chain. What we're witnessing is economic warfare escalating to honestly unprecedented levels. Previous trade disputes focused on tariffs, quotas, and market access restrictions. But this represents something more fundamental: control over the physical materials that make modern technology possible. It's economic coercion at the elemental level, literally targeting elements on the periodic table. The December 1st announcement specifically mentioned the 0.1% threshold for a strategic reason. That seemingly tiny percentage, well, it actually captures virtually all advanced manufacturing equipment, because rare earth materials, while used in small quantities by weight, are distributed throughout complex machinery. You can't simply remove them without redesigning entire systems from scratch, a process that would take years and cost billions. ASML finds itself in an impossible position. The company spent decades developing the most sophisticated manufacturing equipment in human history. These EUV machines represent the absolute pinnacle of precision engineering, optical physics, and material science. A single machine contains over 100,000 parts from more than 5,000 suppliers across dozens of countries. The supply chain complexity is frankly staggering. Now, ASML must either accept Chinese export license requirements, giving Beijing effective veto power over who receives these machines, or attempt to redesign fundamental components to eliminate rare earth dependencies, which could take a decade and cost tens of billions while compromising performance. Neither option is acceptable, yet those appear to be the only choices available. Can the West escape this stranglehold, or has China already won the race for technological supremacy? Subscribe to find out how this economic chess match unfolds.